Did you know the sun is secretly eating Mercury? NASA scientists captured a chilling image. Mercury is dragging a tail 3.5 million kilometers long, racing through space just like a comet. But Mercury is a planet, and this phenomenon shouldn't be happening at all. It's even stranger. Beneath its inferno-like surface, heated to 460 degrees Celsius, scientists found billions of tons of ice. This completely defies common sense. It's the closest planet to the sun, yet it's full of ice. It's barely larger than our moon, yet it possesses a magnetic field. Every new discovery leaves scientists more confused. In 2015, during the final 3 seconds before the Messenger probe crashed into Mercury, it transmitted one last image with all its remaining strength. What it captured revealed Mercury's most authentic appearance. Its surface is covered with massive cracks and craters. The entire planet is scarred and battered. Scientists began to rethink, what kind of violent history did this world endure? Today, we're going to reconstruct the truth Messenger saw before it died and uncover what really happened to Mercury. Back in 2001, German astronomer Gerhard Schmidt was observing from La Palma, Spain, when he caught a stunning sight with a high-precision telescope. A faint but enormous tail trailed behind Mercury, stretching deep into the vastness of space. This tail was 3.5 million kilometers long, equivalent to 9 times the distance between the Earth and the Moon. This discovery completely overturned human understanding because in our solar system, only comets are supposed to have long glowing tails. Mercury is a planet, not a comet. So why is it dragging a tail millions of kilometers long while racing around the sun? Through spectral analysis, scientists discovered this entire tail is made of sodium atoms. The solar wind, like countless microscopic bullets, continuously bombards Mercury's surface. With each strike, sodium atoms are blasted into space, forming this astonishing tail. Mercury orbits only 58 million kilometers from the sun and endures solar storms traveling at 1.5 million kilometers per hour. This relentless bombardment has been torturing Mercury for 4.6 billion years, leaving it bruised and broken. Even more terrifying, Mercury's surface is packed with dense craters. The largest, the Calaris Basin, is 1,550 kilometers across. It was created 3.8 billion years ago by an asteroid over 100 kilometers in diameter. The impact delivered the energy of 1 trillion tons of TNT. The entire planet was shaken out of shape. On the opposite side of the impact point, the surface cracked and was pushed upward into mountains 2 kilometers high, forming the famous weird terrain. Scientists believe this collision fundamentally altered Mercury's internal structure. Those giant fault systems we see today may be lingering scars from that ancient strike. But Mercury's strangest feature is its blazing iron heart. With a diameter of only 4,879 kilometers, barely larger than the Moon, Mercury's core, according to planetary evolution theory, should have cooled and solidified long ago. But Mercury refuses to follow the rules. Its iron core makes up more than 60% of its total volume, and even today, part of it is still molten. No other planet in the solar system is like this. Mars is far larger, yet its magnetic field vanished billions of years ago. So why is Mercury still hanging on? In 2002, high-precision measurements revealed something shocking. Mercury wobbles slightly as it rotates. There is only one explanation for this: a liquid core inside. This discovery rocked the scientific community. It meant Mercury's interior was not the pure iron-nickel alloy scientists once believed, but something different. They now think it's an iron sulfide alloy, rich in sulfur. This material has a much lower melting point, allowing Mercury's interior to remain partially molten even today. But here's the problem. Sulfur is a volatile element. At Mercury's proximity to the sun, it should have been blown away by the solar wind eons ago. So how is it still there, deep inside the planet? There's a fascinating possibility. What if Mercury did not form where it is now? It may have originated farther from the sun and was pushed inward by some catastrophic event. To explain Mercury's origins, scientists have proposed 3 bold theories. The first theory suggests that Mercury originally formed somewhere between Earth and Mars. Then, a colossal asteroid hundreds of kilometers wide struck it, stripping off much of its rocky crust and altering its orbit, sending it careening towards the sun. The second theory is even more violent. It proposes that Mercury formed right beside the Sun, but the young Sun was wildly unstable. Violent solar flares and plasma ejections could have vaporized a significant portion of Mercury's outer layers. Leaving behind the dense metal-rich planet we see today, it would have been a cosmic-scale roasting. The third theory, and perhaps the most dramatic, is the hit-and-run model. This idea suggests that Mercury was once a much larger planet, perhaps the size of Earth or Mars. It then had a near head-on collision with another protoplanet. The impact was so destructive that it stripped away almost all of Mercury's mantle and crust, leaving just the oversized iron core and a thin outer layer. The debris from this collision would have been scattered throughout the early solar system. What was left of Mercury was sent into its current unusual orbit. Each of these theories paints a picture of a planet that has survived an incredibly violent past. Mercury isn't just a small, hot rock, it's a battle-scarred survivor. And this brings us back to the ice. How can there be ice on a planet where the surface temperature reaches 460 degrees Celsius, hot enough to melt lead? The answer lies in the shadows. Mercury has almost no axial tilt, meaning its poles are not tilted towards or away from the Sun, like Earth's are. As a result, the floors of some deep craters at the poles are in permanent shadow. They have not seen a single ray of sunlight for billions of years. In these perpetual twilight zones, temperatures plummet to minus 180 degrees Celsius. Scientists believe that comets and asteroids carrying water ice have impacted Mercury over its history, while ice on the sunlit surfaces would have instantly vaporized. The ice that landed in these permanently shadowed craters could have survived, accumulating over billions of years into the massive deposits we see today. So, Mercury is a world of extreme contrasts. Scorching heat next to ancient ice, a tiny body with a massive churning heart, and a planet that masquerades as a comet. The Messenger probe gave us our first detailed look, but it only scratched the surface of Mercury's mysteries. The upcoming Bepi-Colombo mission, a joint effort by Europe and Japan, is on its way to Mercury right now. It will orbit the planet and provide even more detailed data, hopefully helping us to finally piece together the true story of this enigmatic world. What really happened to Mercury in the chaotic early days of our solar system? Was it blasted by a young, violent sun? Was it the victim of a cosmic hit-and-run? Or was it an unlucky wanderer knocked from its original home? The answers are still waiting for us, locked away on this tiny, battered planet. What we do know is that Mercury's story is a testament to the violent and unpredictable nature of the cosmos. It reminds us that even our own solar system holds secrets that are stranger than we can imagine. Thanks for watching. If you're fascinated by the mysteries of our universe, don't forget to like this video and subscribe for more deep dives into the cosmos. See you next time. Hey everyone, and welcome back to the channel. Today, we're journeying to the most extreme planet in our solar system, Mercury. It's a world of fire and ice, a tiny scorched rock that holds some of the biggest secrets of our cosmic neighborhood. So, buckle up as we uncover the mysteries of this enigmatic planet. From the outside, Mercury looks like our moon, gray, cratered, and seemingly dead. But beneath that quiet surface lies a puzzle that has baffled astronomers for decades. Mercury is weirdly dense. In fact, it has a massive iron core that makes up nearly 70% of its total mass. For comparison, Earth's core is only about 30%. This makes Mercury essentially a giant metal ball with a thin, rocky crust. But why? How did it get this way? Scientists have three main theories. The first is called the giant impact hypothesis. It suggests that billions of years ago, a planet-sized object smashed into a much larger proto-Mercury. The collision was so violent, it stripped away most of Mercury's original rocky mantle, leaving behind the dense iron-rich core. The second theory involves the Sun itself. In the chaotic early days of the solar system, the young blazing Sun might have been so hot that it literally cooked Mercury. Temperatures could have soared to thousands of degrees, vaporizing the rock on its surface. This vaporized rock was then blown away by the powerful solar wind, leaving the heavy iron core behind. The third idea is a story of planetary competition. Imagine the early solar system as a construction site, with planets forming from a disk of gas and dust. In this cosmic free-for-all, Mercury might have lost out. The Sun's immense gravity could have pulled away Mercury's lighter outer layers, like a thief stealing building materials before the planet was fully assembled. So, we have a violent collision, a solar barbecue, or cosmic theft. To figure out which story was true, we needed to get a closer look. That's where NASA's Messenger probe comes in. Launched in 2004, Messenger, which stands for Mercury surface, space environment, geochemistry, and ranging, embarked on an epic 7-year journey across the inner solar system. It wasn't a straight shot. To save fuel, it used the gravity of Earth, Venus, and Mercury itself in a series of complex flybys to slow down and slip into orbit. Finally, in March 2011, it arrived, beginning the most comprehensive study of Mercury in human history. For the next 4 years, Messenger was our eye in the Mercurian sky. It circled the planet over 4,000 times. It's capturing more than 270,000 images and creating the very first complete map of Mercury's surface. And then, in 2012, Messenger sent back a bombshell. It found water. Not just a little, but massive deposits of water ice hidden in the deep craters at Mercury's north and south poles. There could be hundreds of billions of tons of it. You might be thinking, wait, how can there be ice on a planet where daytime temperatures reach 430 degrees Celsius? The answer lies in the shadows. These craters are so deep that their floors are in permanent shadow. Sunlight has never touched them. These dark, frigid pockets. Temperatures stay below a chilling -170 degrees Celsius, preserving the ice for potentially billions of years. Scientists believe this water was delivered by comets and asteroids that crashed into Mercury long ago, bringing a precious gift to this burning world. But the surprises didn't stop there. Messenger also detected traces of organic molecules, the carbon-based building blocks of life in Mercury's incredibly thin atmosphere, or exosphere. This suggests that complex chemical reactions might be happening on the planet. Now, let's be clear, this absolutely does not mean there's life on Mercury. The scorching daytime heat would destroy any life form we can imagine. But finding organics in such a hostile place is a tantalizing clue about how and where the ingredients for life can exist in the universe. Like all great explorers, Messenger's mission had to end. On April 30th, 2015, after 4 incredible years, the probe ran out of fuel. Following a carefully planned trajectory, it began its final descent. It plunged toward Mercury's surface at a staggering 14,000 kilometers per hour. In its final seconds, it transmitted one last poignant photograph. The image, taken from just a few hundred meters up, showed a rough, crater-covered wasteland. It was grainy, blurry, but profoundly moving, humanity's last glimpse of Mercury for a little while. Messenger's sacrifice wasn't an end, but a new beginning. It raised more questions than it answered, paving the way for the next chapter in our exploration. In October 2018, the European Space Agency and the Japan Aerospace Exploration Agency launched BepiColombo. This is an even more ambitious mission, carrying 2 separate orbiters. One will map the surface in stunning detail, while the other will study Mercury's mysterious magnetic field. In October 2021, BepiColombo made its first flyby, sending back incredible high-resolution images that gave us a taste of what's to come. By late 2025, it will enter a year-long orbit, ready to unlock Mercury's remaining secrets. With new missions come new questions. And one of the biggest questions scientists are asking today is, how long can Mercury survive? Every year, the relentless solar wind strips about 10 tons of material from its surface. That might not sound like much, but over 4.6 billion years, Mercury has lost a significant amount of its mass. At this rate, its fate is tied directly to the Sun, but before it withers away, it might face a more dramatic end. Mercury's orbit is strange. It's the most eccentric, or egg-shaped of all the planets. This makes its orbit relatively unstable. Computer simulations by the French astronomer Jacques Lascar have shown that over the next few billion years, there's a small but non-zero chance that Mercury's orbit could become chaotic. It could be flung out of the solar system, crash into the Sun, or even collide with Venus or Earth, adding to its vulnerability. A 2024 study revealed more about its weak magnetic field. It's only about 1% as strong as Earth's, and it's weirdly off-center, offset from the planet's core by 480 kilometers. This asymmetry leaves parts of the planet exposed, making it even more vulnerable to the Sun's constant assault. As Mercury's iron core continues to cool and solidify over billions of years, its magnetic field will likely weaken further, accelerating the erosion of its surface. Mercury's very existence is a miracle. It's too small, too hot, and too close to the sun, yet it has survived for 4.6 billion years. It dances in a strange orbit, holds a blazing iron heart, and carries the scars of a violent cosmic past. It's a testament to the chaos and resilience of our solar system. When Bepi Colombo arrives in 2025, what new secrets will this tiny, tortured world reveal? Will we finally learn how it was forged? Will we find more clues about the origins of water and life? We can only wait and watch the sky. Thanks for joining me on this journey to the heart of the solar system. If you enjoyed this video, be sure to hit that like button and subscribe for more deep dives into the cosmos. Let me know in the comments what you think is the most fascinating thing about Mercury. Until next time, keep looking up.